Hello everyone, welcome back to another video. So in this one we are starting with the planning question, which is without fail always question number 4 of your paper. Let's talk about what you need to take care of when doing this question. Whenever you will be told what you have to do, you will have a statement like this that describe an experiment that investigates the relationship between this and this. So it would be two quantities. Out of this, one of these is what you would change, that's called the independent variable, and something else would change as a result. So that would be the dependent variable. So the first step that you would have would always be to say this, that you vary the independent variable and you measure the dependent variable. Irrespective of whatever is the order that the examiner has given, you would always do this. Sometimes you would also be given this. Okay, so no, before that, you would also be told that there are some variables to be kept constant. These are called the control variables. So all of the control variables that you have, so these should be kept constant to ensure a fair test. So you say that these are to be kept constant. Now the thing that I was talking about, which is that sometimes it would say state additional apparatus that you need. So you can write that here. So whatever are the additional things that you need, you'll write that here. So for example, if it's a length measurement, if the meter rule is not specified in the question, that's what you'll say here. In the fourth one, you just write like a line or two specifying the method. So for example, if it's a electrical circuit question, so maybe you say that you change the variable resistor, you take some voltmeter, ammeter readings, and that's the method in this case. The fifth one is when you basically just talk about like the table of values. And the sixth one is just saying that the conclusion and how it would be reached. Now with the table, as you'll also see in the questions that we do, the column headings are basically needed, and these also need to have so this basically needs to have the quantity, and after the slash it's unit. And the conclusion is always this, that you plot a graph of this versus this, whatever are the two quantities in your table, and you observe the relationship. So that's always the conclusion. Now let's get started with a couple of questions. Let's look at this one. So summer 23 paper 42 question 4, a student investigates the time taken for ice cubes to melt when they are placed in a beaker of hot water. Plan an experiment to investigate how the thickness of the cardboard insulation around a beaker affects the time taken for the cubes in the beaker to melt. The following apparatus is available. So you have 250 cm cube of you have a 250 cm cube beaker, you have a supply of hot water here as well, and then you have your supply of ice cubes, thermometer, stopwatch, supply of 2 mm thick cardboard sheets. In your plan, you should explain briefly how to carry out the investigation, what to keep constant, draw a table with column headings, and explain how you use your readings to draw a conclusion. Again, first things first, even though this is not said, there is a mark for this, what you'll change and what will change as a result. So I will say that I can obviously change the thickness of the insulating sheets, and I will measure the time taken for the ice cubes to melt. So I'll say vary thickness of sheets and measure time for melting. Now what should be kept constant? So what should be kept constant? I guess it makes sense that the volume of the water, the number of ice cubes, the room temperature, all of these you can say are to be kept constant. So volume of water and the room temperature should be kept constant. Don't waste a lot of time with this, because no matter how many control variables you say, you'll be only given 1 mark for all of these. Next you will talk about, what was it, the method. the additional apparatus, if it's specified here we don't need any. So we'll just go on to the method. So we'll say that insulate or wrap around the sheets around the beaker and you say that pour volume of water, the hot water this is, and drop ice cubes measure time to melt using stopwatch. Right, and yeah, so that's what this is. And then what else do we need? So the table of values, okay, so I forgot this one thing. Let me just talk about this here, that when you specify the method, always say that you do this for at least 6 values, right? So you repeat your method for at least 6 values so that you have sufficient values to plot a graph. That's what I'll also talk about here. So repeat for at least 6 different thicknesses. If something like this is said, you can also say that, for example, you repeat the experiment multiple times for a certain thickness and average for the average time. So repeat for at least 6 different thicknesses, and then you say, you talk about the table. So with the table, this is exactly how it's supposed to be. You just need to have the column headings, nothing in the table itself. The examiner won't give you any marks for that. So you say that here you have the thickness. Let's say this is in any desired units, let's say centimeters or millimeters or meters, as long as it's an SI unit of length, and you are measuring the time taken for it to melt in seconds. And then you just say this, that the last point, which is plot graph of time versus thickness to observe relationship. So that was this question. Again, you can see that the method more or less is exactly what we've written. Candidates, so how do they perform with this? That's written in the examiner report. So also a couple of things that you need to keep in mind, and that's why I'm reading the examiner report, is that for example, the diagram is something that you can get rewarded for if your experimental methodology is not very clear, so you can get marks for that as well. And yes, that's that. So you have to have multiple thicknesses. The examiner says at least 4. I always say at least 6 because 6 is kind of a standard in A levels. Identifying a key variable, drawing a table just needs headings along with their appropriate units. You don't need anything in there. Many candidates seemed unaware of the meaning of the term conclusion and instead made predictions. So a lot of the people, they started like guessing how it would affect it. And it makes sense that the thicker the insulation, for example, the longer it would take the ice cubes to melt, but you don't have marks for this. You'll just say how you would look at that. So yeah, so that's basically what you have to talk about. Let's now go on to this question. This is on electricity. This is summer 24, paper 41, question number 4, again planning question. So it's supposed to be question 4. Plan an experiment to investigate how the thickness of a metal wire affects resistance. So it's already given the thickness versus resistance. If you look at this, all of the metal wires have different thicknesses. So you'll vary this and measure resistance, and the equation is given. Following apparatus is available. So metal wire, ammeter, voltmeter, power supply, connecting leads, and a micrometer. And Other apparatus normally available is also there. In this one, so with electricity questions, you'll also always be asked to draw a circuit diagram. So now you start doing this. So you make a power supply, and it's really important that you label these. You have your metal wire here. You'll have your ammeter, which is connected in series. Now you have your metal wire like this, and you have to have a voltmeter in parallel with this here. And then you need to have, yes, so that's basically what you need. If you want to, for example, you can attach like a resistor or something. If you've studied a lot of electricity and you're really worried for the safety of the wire so that it doesn't blow up, so then you can do that, but this is enough. Power supply, ammeter, voltmeter, wire. Done. Now, regarding the investigation, you say that I will vary the thickness and measure. I would say that calculate resistance by measuring current and voltage. By measuring current and voltage and using the formula above. Now, whenever you do talk about these variables, always also talk about what instruments you would use. So it was given above that you use the micrometer for thickness, and obviously you can see the others here. Now you need to move on to the method. So you'll say that for, oh, we didn't talk about the control variables, right? Okay, let's talk about them now. So I guess the length of the wire should also be constant, because if you've studied resistance, you know length can have an impact on resistance, and you should also have the same type of material. So I'll say length and the type of wire should be constant. And now the method. Which is for each thickness note the ammeter voltmeter readings. So note the I and V. I'm just writing this right now to speed this up. Note the IV readings, right? And apart from that, what else would I say? So note the readings, and now you talk about the table of values. Let me just make this here to save time. So for each thickness and its resistance values, so you just write like thickness in any units that you want, millimeters, centimeters, meters, all fly with the examiner, and the resistance in ohms. And finally, for the conclusion, you will say the same thing again, that plot a graph of R versus, okay, don't say R because that's not been used by the examiner, of resistance against thickness to observe the relationship. So that's what this one was about. That's also written here. Most candidates scored partial credit with only a few leaving it blank. So this is, in my opinion, the easiest question on P4. Suitable circuit diagram with a wire or a resistor in series. A voltmeter was expected in parallel either across the wire or across the source. Quality and presentation were variables. Second step was to find thickness. Further credit was given simply for taking readings of current and voltage, which is very obvious. The equation for calculating resistance was provided already, so you don't need to talk about that. Then the control variable, so the length of each piece of wire, but also the material of the wire was accepted. results needed to show at least 2 columns, right? So units are mandatory, and with the conclusion, this is how you end it, right? So just saying plot a graph of the data, a very generic statement, this is not sufficient. So that's the questions that we have for this. Let's just talk about this because I want to like give you a flavor of the different types of questions which are here. So I'll just like go over this really quickly. A student investigates the factors affecting the bend angle theta of a metal strip. The student places a thin straight metal strip on 2 supports, attaches a mass of weight W to the middle of the strip, and the metal strip bends as shown in 4.1. Plan an experiment to investigate one variable affecting theta. There are 3 others which are labeled here, W, D, or D, right? So uppercase D, lowercase d, and W. So you just need to say what you will change and what will change as a result. So the first thing you would say is the same. For example, let's say I go with this, that vary W and measure theta, right? And next, the control variable. So I can say everything that I'm not changing should be kept constant. So I'll say that small d and d are to be kept constant. And here I can use these symbols because these are defined by the examiner. Now, with regards to these things, you will also talk about what to measure and how to measure that. So for example, with W and D, you will say that for W, the weight, you use a force meter, which is the new name for the spring balance, and theta using a protractor. Here you won't talk about why it's difficult to measure or whatever. You'll just say the name and get done with this. And now the investigation. So again, you'll say the same things, that use at least 6 different W weights and measure theta. And then you talk about the table of values here. So the table of values is like this. So you have theta in degrees, you have weight in Newton, and the last thing is again to say that plot a graph of W against theta to observe the relationship. Now that's also written here. Use a protractor to measure theta. Vary either of these and measure theta. More than 2 measurements. Control variables and results and the conclusion. Right? So it's very straightforward once you do get the grip of this. So that basically concludes this playlist, and that's basically all you need to know. So thanks for your time. Like this video, comment if you have any suggestions, share this with your friends, and do subscribe to the channel for more content like this. And I'll see you in the next one.